Since the Big Bang, 13.8 billion years ago, the universe has been expanding. And during this expansion, light from distant objects has also been traveling toward us. As a result, we can observe objects that are now much farther away than they were when they emitted the light we see. The vast distances between stars in the universe present significant challenges for interstellar travel, even for advanced civilizations. Harnessing the energy of stars, or the forces at the center of black holes, requires more knowledge than humanity has. But are there civilizations that have managed what we cannot? These are the Alien Disclosure Files. Since the Big Bang, light has been flowing in every direction for over 13 billion years, and it seems to be expanding faster and faster. But that doesn't mean our universe is only 13 billion light years across. It's bigger than that, much bigger.
Our best guess is that the observable universe has a diameter of about 93 billion light years. That's what we can detect based on Hubble's observation that the light we see, which might already be billions of years old, is getting further and further away from us.
Our ability to observe the universe is limited by several factors, including the finite speed of light, the age of the universe, and the expansion of space. There could be anything out there, including life.
Man is egocentric. We think we are the biggest, the brightest, the smartest, and the most special. So we are the only planet that contains life. But when you look at the vastness of this ever-expanding universe, I don't think that that is true.
Our understanding of the observable universe is continually evolving as technology improves and our observational capabilities expand. New telescopes like Hubble and the James Webb Telescope enable us to explore deeper into space and further back in time, allowing us to learn more about the universe's history and composition.
It's difficult for scientists to imagine aliens being able to find our little planet because of the infinite size of the universe.
As of today, the human race has only been to our moon and back. We may have sent machines to the far reaches of our solar system, but we lack the means to travel to the edge of our galaxy, let alone to another habitable planet.
I mean, there are different ways that you can get from here to there, and one of them is by using black holes, Einstein-Rosen bridges, or wormholes.
Theoretical wormholes, as described by general relativity, are inherently unstable. They tend to collapse quickly, making them unusable for practical travel.
Even if stable wormholes were possible, the energy requirements for creating and maintaining them would likely be immense, possibly exceeding the capabilities of any conceivable civilization.
But it is naive to think that just because the human race can't do it yet, then it is impossible. Humans a century ago couldn't imagine all the technology currently available today. So an ancient race of aliens living on a planet thousands of light years away might be far more advanced than we.
We must remember, I believe that Earth is a relatively primitive planet. In the span of time, we have only been here for millions and millions of years. The span of the universe, this is a blink of an eye. Basically, I think we're the dumbasses of the universe.
There are challenges that we can't answer in the formation and creation of synthetic wormholes. The energy required to create a theoretical wormhole would have to be immense. Where would aliens find a sustainable energy source big enough to create a wormhole? We may not need to look farther than our own sun for the answer. With greater advancements in technology, we have been able to identify the observable universe as having a diameter of 93 billion light years. It's reasonable to believe that there are other civilizations out there in such an unimaginably large area.
There's so many planets and so many that are apparently in the Goldilocks zone that the old idea of us being the center of the universe is a joke. There's quintillion, 70 quintillion planets, and there's got to be life, just the law of averages says.
Wormholes are one option, but creating and controlling a wormhole would take vast amounts of energy. Our civilization cannot access the amount of energy needed to create a wormhole in space. But that's because humanity is considered a Type 0 civilization. This number is based on the Kardashev scale, which ranks civilizations based on their technological advancements.
A Type O civilization is one that's not yet achieved the capability to harness and control all the energy resources available on its home planet. Such a civilization is typically characterized by the use of fossil fuels and the limited utilization of renewable energy sources. It has not yet achieved a unified global culture or a significant presence beyond its home planet.
The first civilization can control their planet. They can control the weather. They can control earthquakes and volcanoes. We are approximately 100 to 1,000 years away from the Type 1 civilization. The Type 2 civilization is stellar, which means that they have managed to harness the power of their nearest star. And for us, that would be harnessing the power of our sun.
This level of energy manipulation allows for interstellar travel, terraforming of planets, and extensive exploration of the galaxy.
A Type 3 civilization has achieved control over the energy resources of an entire galaxy. It can manipulate the energy of billions of stars and possesses the technology for intergalactic travel and colonization.
The third civilization is galactic, which means that they have been able to harness the power of the Planck energy on a quantum level. For this type of civilization, the universe is their playground. They are able to traverse many galaxies. They are able to go down through wormholes, and they are able to bend time and space. For this type of Type 3 civilization, for us to be able to understand what they're doing and how they get here is like trying to tell a dog about quantum mechanics.
The Kardashev scale is a theoretical classification system, but with billions of stars in the sky, that's a lot of energy. And though we may only be a Type 0 civilization, we have already begun the process. Solar power is just the first step of many in harnessing a star's energy. The mass of a typical star is many times greater than that of all planets in its solar system combined. Stars like our sun, for example, have masses on the order of hundreds of thousands of times the mass of Earth.
There are methods of tapping into a star's power. A Dyson sphere is a theoretical megastructure that would encircle a star, capturing all of its energy output. It's often depicted as a solid shell or swarm of solar-collecting satellites orbiting the star.
Stars are the primary sources of energy in the universe. They emit immense amounts of energy in the form of light and heat, and there are billions upon billions of them. But in 2014, NASA's Kepler spacecraft observed a star that dimmed too much for when a planet passes in front of it. The rate and amount of dimming was a mystery, but one potential explanation was the presence of a Dyson sphere.
Tabby's star, boy, that's bothered a lot of astrophysicists. They're still trying to kind of figure it out. It dims and brightens like a variable star or like a binary star, but it's not a binary star. It doesn't have a twin that's less bright that occludes it. And they believe that one possibility is that there could be an artifact built around Tabby's star that causes it to eclipse and causes it to blink.
Tabby's star continues to be a subject of scientific interest and research. Astronomers use various telescopes and instruments to monitor its behavior and gather more data to refine their understanding of the star's unusual dimming events.
It is plausible that if Tabby's star has a Dyson sphere built around it, that an alien civilization might have the technological advancements to create and be able to utilize a wormhole. It would make them a Type 2 civilization at the very least.
While wormholes would require a huge amount of energy to create and maintain, it is a fairly trivial amount compared to how much energy a star produces. We have only begun to harness the energy from our own star, but a more advanced civilization could have figured out how to make the most of their own. And once they had harnessed one, they would have the energy they needed to start harvesting more. And there are certainly lots of stars to choose from. The theory tells us that wormholes could provide a way to travel through the universe at faster than light speeds, as long as we have access to vast amounts of power. With the billions of stars out there, the energy is certainly ready to be utilized. Our galaxy alone is home to intense heat and light produced by stars both large and small.
The Milky Way galaxy is estimated to contain anywhere from 100 billion to 400 billion stars.
The estimated number of galaxies in the observable universe has been a subject of research and refinement over the years. Astronomers estimate that there are approximately 2 trillion galaxies in the observable universe.
Well, we have to understand first off that the universe is 13 billion years old, approximately 13.7 billion years old. And within the span of this ever-expanding universe, there are 7 quintillion planets. Now, if you don't know what 7 quintillion is, put a number 7 and 20 zeros behind it. That's a lot of zeros. So it is a safe approximation to assume that there would be life on other planets.
Galaxies contain a wide variety of stars, ranging from massive, hot and bright stars to smaller, cooler and dimmer ones. Interstellar gas and dust are scattered throughout galaxies. These materials play a crucial role in star formation and can obscure our view of distant objects within the galaxy.
Apparently, without the dark matter, galaxies would fly apart. There wouldn't be enough mass for them to hold together.
But there are other galactic objects that could offer aliens a potential energy source or means of transportation. Objects that are even more strange and powerful than stars.
Black holes. Don't get near one. You know, you don't want to get near one. They'll turn into a little, like squirting toothpaste out of a tube, you know. Time stops at the event horizon, so an astronaut that got close enough to the event horizon is just going to be there forever and ever and ever and ever.
Approaching a black hole is incredibly dangerous due to its strong gravitational pull.
Advanced aliens would need to discover a way to stabilize a black hole. Natural black holes are incredibly destructive and are known for their intense gravitational forces, which can rip apart anything that comes too close. To make a black hole usable as a wormhole?
But if there's a way to get through the event horizon, and people are theorizing that you can, then what you have is an Einstein-Rosen bridge, which is a good way to have a shortcut across the cosmos.
Perhaps at the center of each of the 2 trillion galaxies is a gateway that advanced alien races have perfected. A cosmic bus stop to other places, offering a method of travel that is faster than light. But galaxies are made up of other strange material, dark matter and dark energy.
Dark matter is believed to make up a significant portion of the universe mass. So if it could be converted into usable energy, it would provide an almost limitless power source.
Dark matter is what the universe is mostly made out of. 80 to 85% of the universe we cannot see. We see 15 to 20% of the universe. You know, you can't see it with infrared, you can't see it in ultraviolet light. There's no way to detect it. But it's the missing mass of the universe, in the way that we can see the symptoms that this causes.
As exciting as these ideas are, dark matter and dark energy remain poorly understood. Their properties and behavior are still subjects of active research. But aliens could easily have completed this research and harnessed these mysterious forces.
So it's still science fiction to use dark matter or dark energy in concrete ways? But we're talking about alien races that have developed methods of traveling across unimaginably long distances in the universe. So if true, it's feasible to believe that they have advanced past the theoretical phase and into the practical.
Galaxies are distributed throughout the cosmos, forming clusters and superclusters. At the heart of these massive structures, black holes are often found. The energy and radiation emitted from these massive objects might provide alien civilizations the power they need to visit far-reaching parts of the universe, or maybe our local neighborhood. The universe is expanding, currently at 93 billion light years in diameter and counting. But what is it expanding from?
And what happened during the Big Bang, it not only sent all the carbon, hydrogen, oxygen, nitrogen that life is composed of out into the universe, but it also possibly could have spread, life.
The Big Bang Theory speculates that the universe originated from a singularity, a point in space and time where all the universe's matter and energy were concentrated. At this singularity, the universe was incredibly hot, dense, and tiny. And then it expanded.
Panspermia is the belief that organisms naturally are able to migrate from planet to planet, whether it be through comets or asteroids or meteorites. An example of that, some people actually hypothesize that cephalopods, such as octopus, cuttlefish, and squid, come from another planet because they are so dramatically different zoologically than other animals on this planet in their ability to change shape, change color, and the advancement of their eyes. They are so highly intelligent that people think that perhaps they are a product of panspermia.
And if life developed on Earth, it is certainly possible that whatever vessel brought life to Earth billions of years ago in the form of single-cell organisms could have also crashed into other planets. But why haven't we found anything yet?
The Fermi paradox raises the question of why. Given the vast number of stars and planets in the Milky Way and the age of the universe, we've not yet detected extraterrestrial civilizations. Some theories propose the existence of a great filter, a hypothetical obstacle or challenges that significantly reduces the likelihood of intelligent civilizations emerging or surviving.
I also wonder if this plane of reality here on Earth is actually multidimensional, that we're living in different energy fields. And so on occasion, we will actually see a glimpse of the other energy field.
You know, I lean towards the interdimensional origin of a lot of UFOs. I think it makes a lot of sense.
Perhaps the UAPs we see in the night sky and video on our smartphones are from a different universe. That they aren't scattered throughout the cosmos and the 93 billion light-year backyard we come from, but instead are visitors from another universe. That somehow they found a way, perhaps through wormholes or black holes. It might explain why their aircraft do not seem to follow the laws of our universe or physics.
I think for a civilization that is perhaps type 3 to be able to manipulate the surroundings here on Earth, we don't know how many dimensions are actually here. And like I said, I think the universe has many, many Easter eggs that are waiting for us to find.
An alien race that has developed means of intergalactic travel would certainly be capable of confusing our radar and traveling at incredible speeds in the blink of an eye. A race high up on the Kardashev scale, in theory, has the advancements necessary to achieve such modes of transportation. Our own technology will continue to increase, as will our understanding of the universe. Perhaps, with the right breakthroughs, we might discover how to harness a fraction of the awesome power of this incredible universe and become a UAP to another world.